So we're going to begin with Unit 5, Unit 5.1 specifically. Right? So we're going into 5.1, right? And that's power and institutions. Power and institutions. All right, sweet. So Unit 5, just before we begin, what is Unit 5 all about? Unit 5 is going to be about how do people interact, bargain, and exchange, right? So how do people interact, bargain, and exchange? And then on top of that, how is all of that influenced, right, by institutions and power, okay? So we're going to be looking into that power and institution section and seeing how does that influence the exchange between people. Cool. So two things that you gotta remember, right? Mutual gains are possible. So what does this mean? It means people can work together, right? People are able to work together and they can create mutual gains. Problem is, right? We're gonna have conflict, right? There will often be conflict over the distribution. All right, so we do get mutual gains, you know, like we're going to be using the example with the farmer and the person who owns the land. They are very much able to work together to get mutual gains, but we're going to find that there's conflict over the distribution. And what we're going to learn about is the fact that our institutions, right, are critical to the final distribution, right? And I want you to note that power comes from and influences institutions. Okay, so, you know, the main thing just to recognize that these institutions and power, they're very much, you know, together. You get power from an institution, right? But also power will influence institutions over time. Okay, is everyone good? Give me a thumbs up if we're following me and if we're all around and if we're all focused and here. Great. If there are no questions, I'm not going to see anything in the chat box, then I will carry on. Right, now, like we said, I think that I'm not going to necessarily write it on the board. I'm just going to underline it, make sure that you guys are aware. So we got to remember, what are my institutions? Now, you have been sent notes, right? You have been sent a PDF that includes basically a glossary of everything that you got to know. And one of the big things to remember about is institutions, right? So institutions are basically anything that govern, right? Rules that govern. So you know what, I will write some notes on this. So institutions, rules that govern, okay? And your institutions, they don't have to be written rules. They can also be social customs, right? They can be things that we find is a standard way of doing things, and we sort of all tacitly agreed on it, sort of like in the social contract, you could say. And whether or not it's written or not written, if it's something that people follow, right, some sort of rule of way of doing things, it is an institution, okay? And when it comes to the section that we're in, right, what is the main thing to recognize? So institutions, right, there are rules that govern what people do in the joint project. So the joint project being the people working together, the mutual gains possible, right? People work together for mutual gains. So the rules, the institutions are the rules that are going to govern what people do in the project and how, right? How the gains are distributed. Okay, and I think that you guys will mostly understand this. right? If we, think back to apartheid, and we had terrible institutions, rules that govern what certain people were allowed to do, what certain people were not allowed to do, right? And then we didn't have any institutions that were protecting certain groups of people, and in terms of what gains that they got, and that resulted in, particular outcomes. So that's what we're going to be looking at. Cool. I need a thumbs up if everyone understands this. If there are any questions, now's the time. Otherwise, we're going to move straight on. Right. Just the last thing I want to say is institutions, like I said, it's influenced by power. So just thinking back to like the labor market, for example, we know that the labor market is where a lot of bargaining goes down, and a lot of things like the wage rate and things like that are determined. So, you can think of what you learned about last year in terms of bargaining power, right? If workers have increased bargaining power, they're going to be able to influence institutions, okay? And that's a lot about how this whole thing is going to go on. So with that said, I'm now going to erase the board. Are there any questions? Again, if you want to pop me a thumbs up, that'd be great. But I'm going to give a second to see if a question pops up. Going once, going twice, and I am erasing. Cool. So unfortunately, guys, I don't have my massive boards here at home, which means I can't just keep things up on the board. I do have to keep erasing, which is unfortunate. So just give me a second here. So the next part is 5.2, right? Evaluating outcomes. Evaluating outcomes. And we're just going to sort of recap Pareto efficiency and go into a little bit more detail than we did before. So you're going to 5.2, okay, is evaluating outcomes. And I'm not going to write it on the board, but it's the Pareto criterion. I just want to keep my space here as much as possible. Okay, so remember what Pareto efficiency is, right? You guys must remember what Pareto efficiency is. Pareto efficiency occurs when nobody can be made, actually, right? Sorry, nobody can be made better off. Nobody can be made better off without making another worse off, okay? So Pareto efficiency. No, we can't get extra gains. Nobody can gain more without somebody else being worse off. Now remember, we don't look at the size of gains. So if for person A to get 1,000 more rand, person B has to give up 1 rand, then we're Pareto efficient where we are right now. Because in order for this other person to get anything at all, this other person's going to have to give up something. And even though the amount, you could give someone 1,000 rand, and all this other person would have to do is give up 1 rand, right? Even though it seems like the other one would be efficient, it's not. The other moving to the other place wouldn't be an improvement in terms of Pareto efficiency. As long as you cannot make anybody better off without making anyone worse off, then you are Pareto efficient. Okay, and then that takes us into the next definition, which is Pareto dominance, right? Dominant. So something is going to be Pareto dominant if the allocation allows, right, one or both better off without other worse off. And I think this is kind of pretty obvious from our definition of Pareto efficiency. So we'll say something Pareto dominates another if we can move to that other point without making anybody worse off, and we make somebody else better off. All right, are there any questions? Give me some thumbs up if these are cool with you, and we're gonna go straight to a graph. So I'll assume everything is good if I don't get any questions. Okay, awesome. So let's say we have two people, right? Jesse and Tabiso. And we're looking at the gains that are possible in some scenario where Jesse and Tabiso have mutual gains. And we're going to talk about points A, B, C, and let's put D here. Okay, so we've got A, B, C, and D. Cool. So what do we see here, everyone? How can we look at this? We basically want to see what is Pareto efficient in this allocation, and essentially and in order to determine that, we want to figure out what Pareto dominates what. Okay. So what we're looking at here is what Pareto dominates what. Okay. So we're going to start by very easily seeing that. So let's look at B and C, right? So we can see, right? We can see that C allows for more, right? C allows for more for Jesse and more for Tabiso compared to both B and compared to A, okay? So C dominates A and B. C dominates A and B because C allows for more for both Jesse and for Tabiso, right? In the situation. Now, just a side note that we could see here. I want you guys to see if this was on the same point, right? If this was on the same point, then in this situation, we see that A and B have the same amount for Tabiso, right? But allow Jesse to have more when we go from A to B. So just a side note here, I want you guys to recognize that B dominates A. But regardless of this, right, we do see that C dominates both A and B. So the fact that B dominates A isn't really relevant. I just want to show it for learning purposes. Okay, B does dominate A because Jesse can have more without having an impact on Tabiso. Okay, but we're here to determine what are our Pareto efficient points. Cool. So based on what we've done now, we can kind of cross out B, we can cross out A. Does C dominate D, right? And the answer is C does not dominate D, right? C does not dominate D because to go from C to D, right, we're going to have to give up a lot of Jesse so that Tabiso can have more. Likewise, if we want to go from D to C, we're going to have to give up some of Tabiso in order for Jesse to win. So what we see here is we have two Pareto efficient points, C and D. Because at both of these points, we can't move from one to the other without making someone else worse off. All right, so in this example that we've done now, we've identified that these points, right, are Pareto efficient. Okay, and can we see the green? Just someone type to me if you cannot see. You don't have to give me a thumbs up. If you can't see, let me know. Otherwise, I'll assume green is fine to use. So we've learned about what dominates what is Pareto efficient. And what I want you guys to see is it doesn't talk about fairness. Okay, so the fact that D pretty much has very little for Jesse, right? Whereas C seems to be more equitable, doesn't matter. So nothing, we have not evaluated fairness. And that's something we'll evaluate a little bit later on. But we have not evaluated fairness. We have just looked at, what are the options we should even be looking at to start with. Then we'll start looking at fairness. Any thumbs up if we're happy with this section? If everyone's good, I will move on to the next part now. So give me a thumbs up if we're good to go. Thank you guys. Cameron, Joshua, Byron, Bianca, Latabo. right? Cool. Alicia, Carlos, fantastic. Thank you, guys. All right, so we're going to move on to the next section now, which is my 5.3, evaluating institutions and outcomes. So if there's no questions now, now's the time. Please don't use the green. No problem, I will not use the green. I'll use the green for underlining or for drawing, but I won't write words. Cool. So we're moving on to 5.3, which is evaluating fairness. Okay, 5.3, which is evaluating fairness. All right. Evaluating fairness. And some of this is in your notes. You know, remember the definitions are mostly in your notes. You can always look at this. So when we come to, right, judgment of allocation fairness, right? When we're judging allocation fairness, there are two things that we're going to be looking at, or two types of judgments that we're going to make. We're going to make substantive judgments, right? And what are substantive judgments? This is basically, right, evaluating the outcome itself. So just simply looking at the outcome, the substance of it, right? What's the deal? Why does this person get 1,000 Rand and this person gets 10 Rand? No, why? Why? We're going to evaluate the actual outcome itself. Now, we can't just look at the outcome because, you know, why does one person earn more than another is often for other reasons, okay? So we're going to we're going to have to look at other things, but I just want you guys to understand that substantive judgments are evaluating the outcome itself, and the outcome itself could be anything from income to freedom to happiness to whatever that outcome is. Cool, guys. Also, Dean has just dropped the notes in the chat box as well, just in case one of you guys didn't. You can download it there. Awesome. So the second one, I'm assuming everyone's good. If there's no questions, you can throw me a thumbs up. I don't want to overboard ask it. So the next one is procedural judgments. Right? And procedural judgments are more looking at how the outcome was determined. Okay? So the procedure behind it. How was outcome determined? Okay? And there's a few types of things that we mainly want to look at when it comes to the procedural judgment. So the substantive judgment, there's not a lot to it. You look at the substance, and that's it. Procedural judgments, how was it determined? There are particular types of things that we are going to be looking for. Okay, so what we're going to be looking for are things like this, right? Was the exchange, okay, voluntary and legitimate, right? Was it voluntary and legitimate? Okay, was anyone forced into it? Right? Was there any type of coercion? Was there any fraud? Okay, because obviously that's going to tell us if it's fair or not. The first thing we look at is, was the exchange voluntary and legitimate? The second thing is, was, right, there equal opportunity? Okay, was there equal opportunity for economic advantage? So, you know, was it fair? Was there equal opportunity? And you know, we can give a quick example here, but You know, if we think about again, going back to apartheid, it was clearly, right, there was not equal opportunity. Not everyone was allowed to have certain jobs. Not everyone was allowed to live everywhere. I mean, freedom was restricted for certain groups of people and given to others. So it's very clear that there was not equal opportunity. Let's think then apartheid ends and we have, you know, freedom of movement, freedom of things. So definitely there's an improvement in the opportunity. We can agree on that. I think everyone is allowed to do it what they want. But still, if you live in Kailicha, right, or you live in Rondebosch, the opportunity for economic advantage does differ, okay? So these things obviously live on a spectrum. It's not like a yes, no, tick the box, don't tick the box, right? We're gonna be looking at it like, hey, it's mostly fair, but it's not perfectly fair. That's how we wanna be thinking about these things. Remember, this is very qualitative in a sense. You can't just say yes, no, and it's not perfectly measurable. Cool. And then the last one that we're going to be looking at is did the agents deserve, right? Did the agents deserve their outcome? And obviously relative to one another. So this is also a very difficult one to turn around and figure out. Like, did you deserve it? I don't know. How do we, who says what is deserving? Who says, who says it? And we're all gonna have a different idea of this. So again, it's very subjective, very qualitative, but it is a good way to evaluate things here. So just going back, we've got substantive judgments, we've got procedural judgments. Procedural judgments about how outcomes are determined. We're looking at, was it voluntary and legitimate? That's, I think, an easier one to tick, but still, you know, there could be biases in what you think is fair or voluntary. Was there equal opportunity for economic advantage, and did they deserve their outcome? And, you know, you're going to be looking at things like how much did they work, how much effort was put into it, how many hours, what was the investment, what was the risk? There's so many different things that we could be looking at here. And which one matters more, again, is going to come down to a matter of opinion. All right, give me some thumbs up if everyone understands this, so we can move on to the next section. What is the last line at the bottom of the board? Can you not see the bottom of the board? Economic advantage. Not sure if that's the one you're talking about. Just type me a message if you're sorted. I can't see your name particularly, but yeah, this says economic advantage. Okay, cool, great, you gave me a thumbs up. So that is that. Now, I'm not really going to go into much detail about it, but there's the roles theory of justice. I'm not going to write it on the board, but it's just this idea that social and economic inequalities, right, are justified if there is equal opportunity and if it's to the greatest benefit of the least advantage. So something that's we're going to be looking at, and it's more in the next workshop, is when is inequality okay? You know, sometimes economic inequality is something we can't avoid, and at times inequality could be for the better off of everyone. Okay, and that's what Rawls said. Rawls said, listen, we can either all reduce outcomes, or we can let the rich get a lot richer, and the poor will still be better off as a result than if we were all back down to there. So something to look at is Rawls's theory of justice. I'm not going into depths about it. You guys can read about it on your own, so you have been told. Cool. But the one thing that you do want to understand is when you're making these types of judgments, a very good thing is the veil of ignorance approach. Okay? So I'm just going to write that at the top of the board. The veil of ignorance approach. Cool. So this is Rawls's thing. Rawls, the veil of ignorance approach. And the idea here is if we're trying, so what we're doing is to determine if inequality is fair, right? So Rawls had this idea of the veil of ignorance, and it's a approach to determine if inequality is fair, all right? And the whole idea is basically you say, all right, cool. Has everyone, does everyone have their civil liberty? Yeah, okay, great. So everyone's got their basic equal liberties, freedom of movement, freedom to live where you want, freedom to start whatever business you want, you know, just general basic liberties. Once that box is ticked, and you say, cool. The question then you ask yourself is, you take an outside approach and you say, assuming I don't know if I'll be rich or if I'll be poor. So you don't know if you'll be rich or you'll be poor. Look at the outcome and say, do I think that's fair? So, and then after you've made the judgment to say, yes, it's fair, you might land up being the poor person, okay? So looking at the different options, you'll say, is option A a fair option, given that I don't know if I'll be the poor person or if I'll be the rich person in this outcome. And if you look at it and you say, you know, listen, I think I'm okay with that situation, compared maybe to another situation, then we know that it's all good. Does everyone follow this? Okay, so the veil of ignorance, give me a thumbs up if you understand. Are basic liberties there? Yes? Okay, great. Then all you have to do is evaluate an outcome, not knowing if you'll end up being on the poor side or the rich side. And if you turn around and say, listen, that outcome is the best outcome, in my opinion, then we're good to go. Cool. So if there's no questions, just make a note if you want to go read more about it. It's something worth reading about. It's not something I think that I can really help you much with. Cool. So I just want to know, is everyone's sound okay? Everyone's good here? There's a few people who don't seem to be muted. I'm not really sure why. If you're not muted, please do mute yourself. But if there is any background noise or anything, just let me know. Otherwise, we are going to carry on. Cool, no questions. So I'm going to erase this in a second. Going once, going twice, done. Cool. So the next section is now moving into the nitty-gritty, right? The 5.4, the model of choice and conflict. And actually, to be honest, this is where I get a little bit lost as to which section I'm in. And so the headings don't really mean a lot. But essentially, yeah, 5.4. Model of choice and conflict. Cool. So let's just start with a bit of a recap, okay? We're going to start with a bit of a recap. We're going to recap, right? The feasible frontier, indifference curves, MRS, MRT, right? Optimal choice. Optimal choices. Everyone cool with that, okay? And we're going to start off with the situation, right? We're going to start with a scenario with one person. So just what we remember, one person who owns and farms their land. Their own land, okay. So I'm actually running out of space already on the board. But yeah, I'm going to, so we're going to recap feasible frontiers, indifference curve, marginal rate of substitution, model rate of transformation, and optimal choice. And what we're starting with is a scenario with one person who owns and farms their own, right? Their own land. Is everyone happy with this? Please let me know if you don't get the setup. Otherwise, we're going to carry on. So I actually, unfortunately, didn't write my things here very well, and I am going to erase this board now. So it's just a recap, and we're starting with a scenario with one person who owns and farms their own land. Cool. So I'm going to do this in a very theoretical fashion, and then we're going to do a math example afterwards. So if I'm looking at, we're going to call it grain. It's just any output. and leisure. Okay? Grain and leisure. And I do want you to leave actually space for another graph underneath, but we're going to discuss it later. It's a move when we move on from the recap. So just leave space for another graph underneath. So we've got grain and leisure. Bushels of grain. Remember, bushels of grain is going to become B, and leisure is going to become T for time. So that's what we're going to be working with. All right? And so we've got the feasible frontier. Remember the feasible frontier, FF. So the feasible frontier shows what combinations, or let me actually just write the combinations of B and T that are possible, right? When fully efficient. So we obviously know that we're able to, we're able to exist on the inside of this, but we're not interested on that. We know that we're always going to be at like sort of a full efficiency. So these are the different points that we're able to. Now, what is the slope, right? The slope is equal to the change in B over the change in T while we remain perfectly efficient, right? And that is our marginal rate of transformation. So the rate at which I can trade B for T, right? In order to, it's the rate at which I can trade them, simple. The rate at which I can trade the one to the other and maintain full efficiency. Are there any questions? Does everyone understand? Give me a thumbs up if we're cool with this. Cool, some thumbs up would be appreciated around there, guys. All right, thank you. So the next thing is our indifference curves, okay? Remember we have indifference curves, and indifference curves show combinations of B and T, and it doesn't have to be B and T, it can be whatever's on the Y and X axis, combinations of B and T that yield equal utility. All right? Combinations of B and T that give equal utility. Oh, and obviously, guys, sorry, I just want to note, we're dealing with the absolute values of slopes always. So the absolute value of the slope here, right, is going to be equal to, and this is something you need to learn, it's going to be equal to the marginal utility of whatever's on the x-axis, T, over the marginal utility of whatever's on the y-axis, B. And that is equal to the marginal rate of transformation. Okay? That is my marginal rate of transformation. Has everyone got the part about the feasible frontier and the marginal rate of transformation down? Okay, make sure you get it down because I'm going to erase it in a second. So what do our indifference curves look like? Remember, we can have an infinite number of indifference curves. Okay, I see 1, I see 2, I see 3, and we don't have time to write all this on the board, but basically the higher the indifference curve, the more utility that we have. The higher the indifference curve, the more the utility that we have. Again, I'm going to erase this part right here in a second, so just make sure you've got it. Going once, going twice. Cool. So remember the MRS? So what I just wrote, I said, so the MRS is equal to the marginal utility of whatever's on the x-axis, T, over the MUB. And why is that? Because that's going to be equal to the change in B over the change in T that, that ensures utility remain constant. Okay, so it's a change in B over the change in T that ensures that utility remains constant. So remember, when I'm moving along this curve, any of these individual curves, my utility remains constant. So the rate at which I'm going to trade bushels of grain in exchange for time, so the change in B over the change in T, is going to be equal to the marginal utility of T divided by the marginal utility of B. All right, listen very carefully now. If I value, at a particular point, I value time twice the amount that I value bushels of grain, then I'm going to be willing to give up 2 bushels of grain for 1 unit of time. So that's why we've got T, we've got B over T here, and we've got T over B here. Let's just remember that, right? Tell me if I need to, I'm going to say it one more time and then I need thumbs up. If let's say my numbers here were 2, let's say this was 2 over 1, right? It's saying at the margin, I value time, I value each unit of time individually, twice the amount that I value each unit of grain bushels at the margin. 1 more unit of time is twice as value as 1 more unit of grain. That means I'm going to be willing to give up 2 units of grain in exchange for 1 unit of time. Okay, thumbs up if we understand this, please. And if you have a problem with it or anything, please type a question. Otherwise, I need some thumbs up all around. Okay, I'm going to assume we're good. All right, great stuff, guys. So can you please repeat one more time? Cool, Matthew, no problem. So the rate at which I'm willing to trade. So if we look here, I'll use this point here. So just check me out on the board here. We have some slope. So this is going to show the rate at which I'm willing to give up B to get more T. Can we see that? Right? Matthew, just type a yes. Can you see what I'm drawing here? Right? My slope is going to say the rate at which I'm willing to give up grain in order to get more time. Okay? Now the rate at which I give up grain for more time, let's say I'm willing to give up 2 grains for 1 unit of time. That's because, as you can see here, I've already got a lot of grain and I don't have a lot of time. So the marginal utility of time is quite high and the marginal utility of grain is quite low. So when the marginal utility of time on the top here is high and the marginal utility of bushels of grain are low, then I'm willing to give up lots of grain for a little bit of time. That's why we have the T here and the B here, but the B here and the T here. It's like an inverse almost. It's not an inverse, but you get my point here. We've got T over marginal utility of time over the marginal utility of grain, determining how much grain I'm willing to give up for a unit of time. Okay, so I hope that makes sense to you guys. Some thumbs up around would be cool. And then we're going to move on to the next part. Great. So I'm going to erase here now. So that's my marginal rate of substitution. You guys know the basics of indifference curves, and if you don't you need to go and identify. Right. So when have I optimized? Okay. Anyone want to tell me what is the rule that we know is when we're optimal? What is equal to what? Come type to me in the chat. You guys know I like some engagement. So tell me, where is the rule for what the optimal amount of grain and leisure will be? Can anyone give it to me? I'm giving you a couple seconds. MRS equals MRT. Awesome, guys. Well done. So that's exactly it. We're going to find the point where the MRS equals the MRT. And we know that that's going to be the point where we have tangency, because that's where the slope of the indifference curve is equal to the slope of the feasible frontier. So MRS is equal to MRT. Cool. So we go down, and that is my B, I'm just going to call it star, and my T star. All right, so we know MRS equals MRT is my utility maximization. I've maximized my utility, and that is the best outcome that I've got. Is everyone happy with this part here so far? Are there any questions? Is everyone good? Yeah. Okay, cool. So I'm going to erase this. I'm going to keep this up on the board because I think it's going to be useful in a second. So we're going to do the math behind this. Okay. I'm actually deciding if we're going to do the math behind this now or if we're going to do it just now. Sorry guys, just a second here, a big decision being made. Okay, so you know what, I'm just going to do this and we'll see how this goes. So the second thing I want you to see now here, so this whole situation. Now, how do we figure this out? How do we figure this? Apologies, guys. All right, cool. I'm going to erase the board now. I want you to keep this graph that I've drawn here for later, okay? So we're going to come back to this part of your notes and you're going to fill this part in. So just leave that empty here and we're just going to focus on this. And once you've done the math behind this, to do the next part is going to be easy. But what you're going to see in the next part is that we're going to essentially just look at leisure and we're going to look at utility. So if you've studied a bit, you might know that what I'm going to do is I'm going to make utility a function of leisure only. But that's something that we're going to do a bit later. So keep that axis ready for us to draw some graphs later, and we'll be good to go. Right. So I'm just going to erase the board here. So we're jumping straight into the math now. Math. Okay. We're going to do. So we found the optimal thing on the graph. So now we need to do the math to find optimization. Okay, the math of finding optimization. Okay, so we're going to do two things. We need to first see the information that they're going to give you. And I am using the standard examples that they've provided in the textbook. So we're going to say the utility is a function of T and B. And the utility function is defined as T to the power of 0.2 times B to the power of 0.8. So what this is saying is utility here is a function, right, of my leisure time and the bushels of grain that I'm able to consume. Does everyone understand that? Right? The second thing is to now say that B is equal to, right, 28 times h to the power of 0.5. So what is h, right? What is my h? So this is the information that you're going to get provided. And then they're going to say, find the optimal. So the maths, find optimal, right, T and B. So find the optimal T and B. And this is the information that will be provided for you. Now, what is H? So H is equal to hours worked. Or work, let's just call it work hours. And work hours, what are work hours equal to? Work hours are equal to 24 minus T, right? So we know H is equal to 24 minus T. And this is really important. They're not going to give you this information, but it's fundamental to your whole setup. So it's essentially like one of these bullet points, okay? When they don't provide it to you, you need to understand that that is critical information that you are going to be starting off with. So I hope everyone understands the problem that we'll be working with. I'm going to use this problem, right, to find the optimal T and B. We know what we need to do. We need to, so what is the end goal, right? To find, actually no, I'm just going to speak it out so you guys will get it. To find the to find the optimal allocation, we've already said it, we need MRS equal to MRT, right? We need MRS equal to MRT. So to find MRS equal to MRT, we need to do math, okay? So the first thing we do is find the MRS, okay? We need to find the MRS. Now remember what the MRS is equal to. The MRS is equal to the marginal utility, right? The marginal utility of T over the marginal utility of B, okay? What is the marginal utility of T in math when I look at this utility function? It's going to be the derivative of my utility function in terms of T, so it's what we call a partial derivative, and that's going to be divided by the marginal utility of B, which is the derivative of the utility function in terms of B, okay? So MRS is equal to the marginal utility of T over the marginal utility of B, and what we do to get that is we need to take the partial derivative of the utility function in terms of T, and then divide that by the partial derivative of the utility function in terms of B. Okay, So I hope that you guys, I hope that makes sense to everyone. I'm going to carry on here with the math. If there's any questions, now's your time to ask me about this before we carry on. Okay, going once, going twice, we're good. So just feel free to, just throw a thumbs up through there whenever you feel like it. All right, so let's start with the utility, the derivative of the utility function in terms of time. So, this isn't a math class. You're going to see this is not a math class. I can't go into the details of partial derivatives and all this stuff too much. But basically, for those of you that I can try and assist just a little bit. We're going to derive this utility function, but anything that is not t is going to be treated like a constant. So, if this had said t to the power of 0.2 times 5, right? Then we know 5 would be the constant, there would be no other variables, and we would just leave 5 alone because it's being multiplied by the t here. And we would derive the t, and 5 would stay where it is. Similarly, b to the power of 0.8 is going to stay there, right? So we're going to do the derivation like we would on t. We take the 0.2 down, times by t, we take 0.2 minus 1, so it's now minus 0.8, all right? Multiplied by b to the power of 0.8, right? We then take the derivative, right? We take the derivative of the utility function in terms of b, and we do it the exact same. We do it the exact same way. Okay, I'll come to that question in a second. So, well, I'm just going to do it again. Partial derivative. Okay. Let me take a step here. What is a partial derivative? It is finding the change in utility. So this partial derivative here that I'm pointing at, du over db. It's finding the change in utility that occurs when there's a change in bushels of grain. All right? So the change in utility that occurs when there's a change in the bushels of grain, holding everything else constant. That's what a partial derivative is. It's finding the rate of change of one thing when something else changes, holding all the other variables constant. Okay? So when we partial derive, we treat that other like a constant. So t is going to be the other here. So we're only going to derive the b part. Okay? So the 0.8 comes down, times by b to the minus 0.2, and then we just leave the t to the power of 0.2 on its own. All right? So let me know if that answers the questions about the partial derivatives, right? At least how to do the partial derivative. What is the partial derivative? It's the change in utility. So the partial derivative of the utility function in terms of time. What is this? The change in utility that occurs when there's a change in time of leisure. And guys, in your theory, what is that? That is the marginal utility of t. Because the marginal utility is the extra utility you get, right? When there's a change in time. And that's why we use partial derivatives. Cool. So to get my MRS, I'm just going to put this on top of this. All right? So my MRS is going to be equal to the 0.2 to the power of t, times t to the power of minus 0.8 times b to the power of 0.8 over, right, 0.8 times b to the minus 0.2 times t to the power of 0.2. Okay, so in doing our maths here, again, this is not a math class, but I can give you some quick tips. All right, so please look here. Where we have a negative on the exponent, we know that we can then drop it in our fraction from the numerator to the denominator and take the negative away. Likewise, if you have a negative on the denominator, so if you have a negative exponent above a variable that sits at the denominator of a fraction, then you can take that variable and put it on the numerator and just remove the negative. So I'm going to do this slowly just to help you guys, but I don't want to spend too much time on it. This becomes 0.2 the B goes up, so it's B to the power of 0.2 times B to the power of 0.8 over 0.8 times the T goes down, T to the power of 0.8, right, times by T to the power of 0.2, okay? And if I then simplify this, 0.2 divided by 0.8 is 1 over 4, right? 1 over 4 times by the B to the power of 0.2, B to the power of 0.2 times B to the power of 0.8 just come together. You know, you can add when the you can add the exponents when they're multiplied against each other, all right? So we've got B, 1 times B over 4 times T, okay? In other words, B over 4T. So we have found our MRS. We have found our MRS, B over 4T. But is there any questions about the math? I know I keep saying I'm not the maths guy, but you can ask me if you have any, right? So please, if you have any questions about the math, now's the time. Otherwise, yes, I need a round of thumbs up, right? Just to tell me that I'm good to go. Is everyone good? Are there any questions? Okay, we're solid. Okay. Okay, cool, guys, fantastic. So the next thing we're gonna do now, so well, let's just first of all, I know I might be, I hope that I'm not taking too much time on this at the expense of things later, right? But what I want you to understand is sort of this this thing. So why the MRS changes, right? So the MRS, the marginal rate of substitution, is a function of B and T, and it makes sense because if you remember the graph, it's convex. So the MRS changes. The MRS changes depending on how much B and T we have. So if B is high, so if B is high, right, and T is low, okay, then we're gonna see we have a high MRS. And this makes sense because, right, the marginal utility of T, this is over the marginal utility of B, right? Big, sorry, just need to make space here. So let's actually do it this way around. What is the MRS, right? MU of T over MU of B. So I need an answer, guys. I need an answer. Give me an answer. If I have very little time, will my marginal utility of time of leisure be high or will it be low? Give me an answer. If I don't have a lot of time, am I going to have a high marginal utility of time or a low marginal utility of time? Talk to me, talk to me, talk to me, talk to me, guys, talk to me. So I don't have much time. Am I going to value time highly or low? Okay, so I'm not getting any answers here, but I think we should all know that exactly if I don't have a lot of time, I value my time highly, which means I'm going to have a large marginal utility of X. And because I have so much B, right, I'm going to have a small marginal utility of B. And therefore, right, the MRS will be high. Okay, so if B is high but T is low, right? We have a large marginal utility of time. We don't, because we've got very little time, we value time greatly, but we've got lots of grain. So we don't value more grain very highly. Actually, it's very low. We've got a small marginal utility of B because we have a lot of B. Therefore, the marginal rate of substitution will be high, right? Because what is what is the marginal rate of substitution being high saying? Right? Change B over change T that keeps utility constant is high. Willing to give up give lots of B for little t. Okay? So what I'm basically getting at here is if the marginal rate of substitution is high, it means, right, what is the marginal rate of substitution? It's the change in B over the change in T that keeps utility constant. And we see that it's high here. So what we're saying is we're willing to give up lots of B for little t. And that makes sense because I've got so much B and I don't have a lot of t. All right, so that was a side step out so that we understand how to interpret the marginal rate of substitution. Please tell me if you have a question now. Otherwise, round of thumbs up because this stuff is very complicated. And if you get it, I need to know that you get it. Cool. And if you don't get it, then you need to tell me in the chat. Okay, I won't see that you didn't give me a thumbs up. Okay, when I get a lot of thumbs up, I move on. Cool. We're good to go. So I'm going to erase this now. I'm going to erase this because I need the space. So we're going once, we're going twice. Okay, sweet. So we got our MRS. We now need to get our MRT. So to calculate the MRT, what are we going to do? Right? So we need the MRT. And what is that? It's the change in B over the change in T along, right, the feasible frontier. Okay? Along that feasible frontier. Now, what is my feasible frontier? My feasible frontier is not in terms of H, which we were given, right? It's not in terms of H, which we were given. It's in terms of time, right? The feasible frontier is the change in B, is the B and is the line that shows the combinations of B and T that are possible, okay? But it's not the production function itself. So remember, we need to find the feasible frontier first. And what is my feasible frontier? So the FF is going to be equal to B, right? B, no, sorry, how do I, so it's not equal. Apologies, it's not equal. The feasible frontier is not equal to something, but this is what represents the feasible frontier, all right? B, which is on my y-axis, is equal to 28. And instead of writing H, we now replace H with the equation where H is a function of T, okay? So remember we had an H here, but we know that H is also equal to 24 minus T. So we plug that in there, and we call that to the power of 0.5. So just remember that, guys. What have I done here, right? What have I done here? I have just simply replaced, I have put H here, because we know, right, B is a function of H, right? B is a function of H. So I can replace it, so then instead of having H, I show B as a function of 24 minus T. All right, so please give me a thumbs up if we follow this, and then I'm going to move straight on. Okay, cool. So to get the marginal rate of transformation here, the MRT, right? What do I need? I need the slope of this. I need the slope of this function. In other words, I need dB over dt. Okay? And again, I'm not going to be able to go into a lot of the math behind this. So if you need to review your math, please do. But there's a chain rule that's going to occur here. So remember, we're going to be working with the absolute value. So the chain rule part doesn't really matter a lot. But you're going to see what I mean. So how do we do this? We first derive the function here, and then we derive the inside function. Remember, that's how we do the chain rule. So what we would do is we would treat this like this like a variable, right? The h, the 24 minus t, okay? And we're going to take the 0.5 down, multiply it by 28. So that's 14 right? 14 times by 24 to the minus t to the power of minus 0.5. And then what we do is we derive the inside function, right? And remember, the derivative is in terms of t. So we look at the t here, and we see the derivative of 24 minus t is, in terms of t, is going to be minus 1. The 24 falls away, and the t falls away, and it becomes times by minus 1. Okay? So, remember, it's the outside derivative times by the inside derivative. That's a MAM 1010 stuff for you. And if you need to go review that, please make a note right now to review the chain rule. All right? But I don't think it's going to get much more complicated than what we've done here. Right? Now, what you're going to see is that this absolute value, it cancels out this effect anyway. Okay? So we don't really have to worry too much about it. But yes, my MRT, right? My MRT is going to be equal to 14 minus t, 14 times 24 minus t to the power of negative 0.5. MRT sorted. Are there any questions? Is everyone comfortable with how we calculated the MRT? Please put your thumbs up if you are. Going once, going twice. I'm waiting for questions. I'm going to give a moment for questions. So I'll talk a little bit more. But if you've got any questions, now's the time. So what we did was we found the MRT, which is the change in B over the change in T along the feasible frontier, right? In order to get our feasible frontier, we took our production function, B of H, B as a function of H, and we turned it into B, a function of 24 minus T, right? So we got our feasible frontier. We then found the marginal rate of transformation, the derivative of this B in terms of T, which required us to apply the chain rule, and we were able to calculate the marginal rate of transformation. So boom, we know we're good to go, and we can carry on. I will leave this on the board so that you guys can, if you guys haven't noted it, I'll carry on here and then I'll erase. Great, so the final step, right? Oh, and yeah, I think you can interpret this as you see fit. I don't think the interpretation is too heavy, but you can see it negative t here, which has implications. So the next final step, right? So this was step 2. Sorry, I wrote a step 1 next to the MRS. So this is step 2, and step 3 is set MRS equal to MRT, and right, and plug in the feasible frontier constraint. This is really important because if we think of our graph, right, where we have tangent theta, we set MRS equal to MRT here, but we actually, if we just set MRS equal to MRT, we could have MRS equal to MRT here, we could have MRS equal to MRT here, right? There's lots of different points where the MRS could equal to MRT because you haven't defined, right? You haven't defined the feasible frontier. So we don't just set MRS equal to MRT, but we have to plug in the feasible frontier constraint to ensure that that is satisfied as well, all right? To ensure that that is satisfied as well. So we're going to start doing that over here, all right? We are going to set MRS equal to MRT. So we see it B over 4T is equal to, right, 14 times by 24 minus T to the power of minus 0.5. Okay, so what have I done here? I've set my MRS equal to my MRT. Are there any questions about this? I think we should be happy with that. I'm going to erase the top now. Okay, cool. So as you can see as well, here's the issue, right? If I just say MRS equal to MRT, I have an unknown B and I have an unknown T, and that's what I was talking about, right? We haven't defined the constraint. So what we would actually find is a relationship between B and T for all possibilities, right, of tangency. But that doesn't help us because we need specific answers. So what we're going to do here is we're going to plug in our feasible frontier constraint right here. All right? We're going to see now, instead of this having the B part here, we're going to have, so B is equal to 28 times by 24 minus T to the power of 0.5. That is my B. If I had a number here, guys, I'd have to include it there. If it was 2 times B, it would be 2 times that, okay? Over 4T, right? Over 4T. We set this equal to, right? We set this equal to what we had over here, our MRT, which is 14 times by 24 minus T to the power of negative 0.5. All right, and then we to get, what does this do? So first of all, once you get to here, this is the home stretch. Okay, this is MRS equal to MRT with feasible frontier constraint included, plugged in. So in other words, they're both satisfied, right? Our marginal rate of substitution and our marginal rate of transformation is satisfied, and our feasible frontier constraint is also satisfied, okay? So we've satisfied the 2 things that we need, MR is equal to MRT, we've satisfied the feasible frontier, and we can essentially solve. Guys, I don't think that me going through the math now is worth our time because we still have quite a bit of stuff to work through. But basically, you would, to get out of this, this problem here, you would multiply both sides by 24 minus T to the power of 0.5. So if you want to see, if you want me to repeat that, I'm going to say you would multiply both sides by 24 minus T to the power of 0.5. When you multiply this side by 24 minus T to the power of 0.5, the 0.5s fall away because you put them together and you just got 24 minus T. When you do it on this side, you got 24 minus T to the power of 0.5 times by 24 minus T to the power of negative 0.5. So they're going to cancel each other. So you would have 14 and you would have that, right? And you could solve. So I'm going to leave it there for you guys. I'm going to tell you the answers. So solve for T, and we see that T is equal to, right? We see that T is equal to 8. So this is a good exercise for you to go home and, oh, you're already at home. Funny. But you are welcome to laugh at my jokes over the chat. You can practice this one on your own at home. All right? So solve for T. Once you've got that T, right, you plug T into the feasible frontier. So in this case, we would say B, right? What was B equal to? B was equal to 24 minus T to the power of minus 0, no, sorry. B was equal to 28 times 24 minus T to the power of 0.5. So B is going to be equal to 28 times 24 minus 8 to the power of negative 0.5. And so your answer for B is going to be 112. So you got your T, you got your B, and you're sorted, right? If you wanted to, you could find utility, right? We would just plug in the utility numbers, and we would find the utility is equal to 112. So these are some, oh, sorry, not 112, 66. Point, I think it's 07. But yeah, or 67. But don't stress, you can figure that out. Cool. Ask questions now, or forever hold your peace. Going once, going twice. We're good. Okay, cool, guys. So it's 11:24. We started this workshop a few minutes late. We have said in all of our emails out about workshops that there's a potential for an extra 30 minutes because of this whole Zoom thing and, you know, because of me and the way that I do things. So I'll answer that question in a second. But basically, we're going to take a 5-minute break now. It's 11:25. We are going to take, it's 11:25 right now. We are going to take a 5-minute break and reconvene at 11:30 sharp. And I'll answer questions in the meantime. For those of you that are comfortable with everything, you can take a quick break. So the feasible frontier, thank you. Have I made an error? I've made an error. Thank you. So for those of you that are, before you walk away, right, the negative goes away. Thank you. No negative. No negative on the exponent. Very good. Thank you. All right, so you guys can take a 5-minute break and we'll reconvene at 11:30 and expect us to work for a full hour after that. All right, great. Okay, guys, we're going to be going back in 2 minutes. 11:28. We'll be back in 2 minutes. So for those of you that are with me now, you can tell I'm just redrawing those graphs that I told you to hang on to. Cool, we're gonna be starting in a minute or just under a minute. Actually, no, we're gonna be starting in 30 seconds. So if you are not at your table or your desk or wherever you are doing this, but you are available. If you're not at your desk, but you're at your room, sit down. Time to start. So if you can hear me wherever you are in your house or your room, let's get back to it. The notes have been sent in the chat. So if you can, someone just asked the question, where can I find these notes? They have just been sent in the chat. Do you see them there? Right? I will send them one more time if needed. Remember, the notes are they're not complete, guys. The notes are not complete. It's more just like a glossary. Cool. The notes are coming now. Okay, cool. We're going to begin. I need thumbs up. Give me some thumbs up that everyone's around, that we're back, that we're here, that we're ready to learn. Give me some thumbs up, please. Right? Cool. We're here. We're here. Fantastic. Thank you, guys. So glad to be with you all. Awesome. Cool. So, what are we doing now? So let's just look at what we've done. What we did just now was we calculated the B star and the T star, right? So if we were to graph, if we had to draw this, right, you would use your math skills to find the intercept of the feasible frontier, right? You would use your math skills, which would just be take the feasible frontier, set B equal to B equal to 0, and you'll get T intercept. Set T equal to 0, you'll get the B intercept. You guys should know that. The hard math that we did was to find this and this to find that. So if any point you're asked to draw this, that's what you're going to be doing. But I don't know if you'll be doing that, because I don't know what the assessment is going to look like. Anyway, the point is that we can express this in another, we can calculate this in another way. We're not going to do an example of it, but you do just need to know it, okay? So it is possible, right, to find the point where utility is maximized, right, as a function of T, So we can find, right, T star, right? We could find T star by, so find optimal T by finding, or sorry, let's just say, by setting we're just setting du dt equal to 0, right? Du dt equal to 0, right? We can find T star. But to do this, right? To do this requires that we show, let's just say that we have utility as a function of T only, right? And this is possible, right? This is possible because we know, I'm going to carry on here, that utility is equal to a function, U is equal to U of B and T. But what were we able to do, guys? We were able to find B as a function of T. Because remember, how much grain I produce is dependent on the number of hours I work, and the number of hours I work can be expressed as a function of the amount of leisure hours I produce. Right? So I can say U is equal to U of, right, B of T and T, which basically just says U is the utility function of time. So what we're saying here, right, is this main thing here. That I can essentially I can show B as a function of my leisure time. And once I've done that, I've made utility a function of T only. Okay? So how we would do that, right? How we would do that, and again, I'm not going to go into the big math of it, but given what we were earlier, right? We know that U was equal to b to the power of 0. T to the power of 0.2 times b to the power of 0.8. And essentially, we would say u is equal to t to the power of 0.2 times by, and we would replace b with that function 28 times by 24 minus t to the power of 0.5, right? So remember, all I've done is replace h here. Then, right, take the derivative of the utility function in terms of t, set it equal to 0, solve for t. That is how you would do this problem. Okay? This would be the most fundamental part of the whole thing, right? But you've got to make sure you set it up properly. And I think, again, that's where I'm most useful, is just to show you how to set it up. Okay? How you set it up. Also, what I want you to see is that this utility function that I've drawn here, right? This utility function that I've drawn here is this function here, right? U as a function of t only is this function that we've drawn here. All right, give me a thumbs up if we understand what I'm saying, and if there's something specific you want me to, just let me know. Does the power of 0.8 fall away? Very good. Thank you for that. No, it doesn't fall away. Very good. So we would, where's my black marker? We would put brackets around this as well, and we would put to the power of 0.8. Okay, thank you for that. Wait. Yeah, I think that's correct. Please check me, guys, as you do. Yeah, that b is equal to 28 times by 24 minus t to the power of 0.5, and we have to put the 0.8 there. Thank you guys very much. Cool. So well done. Very great question, Jared. You made sure that we didn't make a big mistake here. So now the reason I'm not doing the maths, this maths is quite intense. Okay, this is quite intense maths. I don't even know if they're going to ask you to calculate this math. I really don't know. But you do need to understand the theory behind it. So what we've done here is we've set the utility function as a function of t only by replacing b with the function of, with b as a function of t. Then, if you were to have to, you would, this utility function that we've set up is the function that I've drawn here. We would derive that utility function, set it equal to 0, and we'd solve for t, and that would give me my t star. We can then use that t star to calculate how much b we're consuming as well, right? So we could solve for t, and then we could solve for t. Are there any questions? Give me some thumbs up if we understand this stuff. If we do, we are done with the math section. We're going to move on to what this chapter is really more about. But it is a bit of a simpler section. So we're sort of on the home stretch. Not quite, but we don't have too much left. Okay, cool. Guys, I'm really enjoying seeing you guys today. It's been great doing this. It's weird not to see you, but it does feel good to be back in the classroom, kind of. So thank you guys for joining me here today. Okay, cool. So we're now going to carry on with 5.5. Right? The technically feasible. Right? Technically feasible allocation. But I'm not going to write the word allocation. So the technically feasible. You solve this. Matthew, I'm going to be honest with you. My maths, it's okay. It's pretty good on a basic level. And then when we start to get very complex, I'm not 100% sure. So that's something that I'm going to have to ask you to go and check on yourself outside of this workshop. There's a lot of math resources out there that can help you with that question. But I'm fairly certain that it's 0.5 times 0.8. I'm fairly certain that it's, that if you've got 2 to the power of 2 to the power of 2, it just becomes 2 to the power of 4. So you can also play with numbers, some basic numbers to find that out. But yeah, I think that that's something you're gonna have to go look into yourself. So technically feasible, right? If you look at your notes, you got some definitions, right? We've got biologically feasible, right? An allocation that is capable of sustaining the survival of those involved is biologically feasible, okay? And then we've got technically feasible, which is the allocation within the limit set by technology and biology. So that's what we're going to be looking for. What are the allocations that we can do? So we've got a new setup, okay? Now, two people share the B output. Okay, I am using the standard example, right? So we've got Bruno. I should use a new name, but for fun, but hey, we're not going to like the name Bruno. Bruno owns land, and Angela has farming skills, farm skills, okay, farming skills, right? So Angela knows how to work the land, Bruno has the land, okay? So we're going to look now at what is, just simply technically feasible for them to share, okay? So just starting off with the actual graph. So let's start by drawing the graph. We've got T, and we've got B. So the idea here is on our graph, T on our graph, T is equal to Angela's leisure, and then B is equal to output, and that's going to be shared. So it's the total output, right? And then we're going to work out how much of it is shared. So T is Angela's leisure, not like become both of their leisure, right? And B is the output that's going to be shared. Why do we know it's going to be shared? Bruno owns the land and has to work. Okay, cool. So now we still got a feasible frontier, and this feasible frontier is for both of them now, right? So again, for A and for B, for Angela and Bruno, this is the feasible frontier that represents what they are going to share collectively. Okay, and now we're going to draw what we call Angela's biological constraint. So her biological constraint is the minimum that she requires. Okay, is the very minimum that she requires to stay alive. Right. So this is A's bio constraint. Okay, this is A's bio constraint. So the biological constraint is just simply the minimum amount that you need to pay Angela, that you need to feed Angela with grain in order for her to stay alive. It's a very grim story that we've got here, right? So if Angela is not working, if she has 24 hours here, right, then she doesn't need as much grain because she's not using as much energy. But as you take leisure time away from her, and the assumption is therefore we have Angela working now, then we see that Angela requires more and more and more grain as a result of that. Does everyone understand? Please give me a thumbs up if you do. Okay? So that is her biological constraint. Now, due to her biological constraint, we can now see, right, what is the technically feasible, right? So this is my technically feasible allocation. All along here, including on the line, right? Including on the line. So we can have a situation where Angela gets this much, right? And Bruno gets the rest. Or we can have it somewhere in between and so on. So all the technically feasible allocations exist in between the feasible frontier and Angela's biological constraint. Okay, so if we understand, give me some thumbs up. If we don't understand, then say so in the question. Otherwise, we're going to move on. That is what is technically, biologically feasible. Okay, cool. So the next thing then is, so let's assume, so let's start with the first example, which is 5.6. Allocation by force, right? Force or coercion. I misspelled something, coercion with an S? No, it's with a C. Okay, so I'm going to stop using A and B because I can see that this is going to get confusing. But yeah, so we've got allocation by force. So if you want to, you can work with this graph, although we're going to just draw another graph, right? So first, let's just understand this idea, right? Allocation by force. The basic idea is that let's say, you know, Bruno has immense power over Angela. Bruno can essentially tell Angela what to do. So almost like slavery situation, okay? And he can enforce any allocation he wants as a result of that. So he owns the land, and she has no particular rights in terms of what she can earn, and he can tell her, this is how much you need to work, okay? So the question is, what is he going to choose, right? What is he going to choose? So let's draw this line. Let's this thing up, and we're going to draw another graph underneath it. Okay, and we're going to put B for bushels of grain here, and we're going to put T here, which is Angela's chill time. All right, so we draw our feasible frontier. Okay, and we look at we look at her Angela's biological constraint. Right, so this again, we're still working with the bio constraint. Now, guys, I need everyone to look at the board. Okay, so look at your notes. Look at the board. What we're going to be drawing down here is we're going to be drawing Angela's time, right? And then we're going to put Bruno's B. So how much grain does Bruno get? Okay, so watch me again. Watch me, please. If we allow Angela to work this much, if we allow Angela to work this much, then we have to, Bruno has to pay Angela everything that she produces because she needs it to survive. So if he gives her that much, he's going to get nothing. So essentially, you can see the biological constraint as the amount. The biological constraint is how much Bruno needs to give Angela in order for her to keep working the land. She needs to survive. All right? So if the difference between these two is going to be, if the difference between these two is going to be what Bruno wants, then what do you think, guys? He's going to want to find the point where there's the greatest difference here, right? Because they diverge and then converge. So there's a point that we can find where there's the greatest distance. And that point that we're going to find where the greatest distance occurs is the point, right, where the slopes are equal, right? That is going to be the point where the slopes are equal. So it's at this point that I can see, right, at this T star, we can see that the MRS of Angela's biological constraint is equal to the MRT of the feasible frontier. Okay, so I'm going to write that here. At T star, Bruno, well, first at T star, MRS of the bio constraint is equal to the MRT. All right? So at T star, we see the biological constraint is equal to the M marginal rate of substitution of the biological constraint is equal to the MRT. Okay? And we can see that that is the point where we maximize, right, Bruno's, right, outcome. Bruno's B is maximized at this point. Okay, so therefore, optimal for Bruno. So we can see that the amount of B that he gets here is at its maximum, and the 0 point, right? The 0 point would actually be, sorry, where these are touching. Okay, so we see that this is the maximum amount of economic rent, essentially, that he can get. So Bruno's B is maximum, or you can also say his economic rent is maximized. Okay, I need some thumbs up if we understand this stuff, right? Please ask me some questions if you need to. Going once, going twice. Cool, well done, guys. So, you know, they haven't gone into, I haven't seen anything where they've you know, asked you to do too much math, although I didn't have time to look at everything out there. But essentially, what would be the math here? What would be the math here? We would set the MRS equal to the MRT. We would solve for the T star, right? And then we would plug it in to the biological constraint in order to solve. So I don't think it's something they're going to make you do, but you can always follow this here. All right. So remember, this is Bruno's amount. I'm not going to do numbers here as well. But if you had a 12 here and a 6 here, right, then we would know who gets what. So I will write it out here, right? So if I look here, this is for Angela. Angela's bushel of B. And this amount here is going to be Bruno's B. Okay? So we've got Angela's B, right? He's paying her the minimum amount to keep her alive at T star, right? And he is taking the rest of that. So given a graph with some numbers, you would be able to calculate what is Bruno's B and what is Angela's B in this situation. Okay. I need questions now, if there are any. Otherwise, I'm going to move straight on so that we can get this stuff completed pretty soon. We don't have much left. Thumbs up around if you've got any questions. Let me know in the chat room now. I'm going to give you a moment just to absorb everything. Please explain how the top graph links to the bottom graph. Definitely. Thank you for asking that question. So Bruno, right? Remember what I just said here, Bruno's B. So Bruno's B is going to occur here. Bruno's B is maximized. So the amounts here that we see are the differences here. Yeah, do we see that, right, Maxine? If I were to calculate the difference here, right, and if I took that down, that would be the difference here. Likewise, the difference here, if I took it down, would be equal to that difference there. Maxine, we're good. Awesome. So we can see that he doesn't want to be here. He doesn't want to be here. He wants to be here because that's where he will maximize his payoff out of the situation. Okay, cool, guys. So Anybody else? Anybody else got anything to ask? Anyone? Going twice? We're good. Okay, awesome, guys. I'm glad that you are learning here clearly, I hope. I'm going to erase this, going once, going twice, done. Right, so we're now going to move into economically feasible, right? So we've done the technically feasible, and we've done the coercion example. So the coercion example, you know, is that example? If you only have to basically keep someone alive, that's the only constraint, and all the institutions and power in your favor, and you're also just someone that's okay with that, then that's how you make your decision. All right? And that's what I want you guys to get out of it. Okay, so 5.7, the economically feasible. Right, 5.7, economically feasible and surplus. But yeah, I'm not going to write it all out. So we're going to carry on now with a similar graph where you've got B for grain and T for time, and we've got the feasible frontier, which we now know represents the amount of grain that they have to share for every level of Angela's leisure. Okay, so now first we're going to just draw in the biological constraint. Okay, so first we just draw in the biological constraint. Okay, we've got our biological constraint there, and now what we essentially want to derive is Angela's reservation indifference curve. Okay, so what we're going to derive now is Angela's reservation indifference curve. All right, and to do this, right, we're going to have to define something else, which is her reservation option. Right, now in your definition, you've got the reservation option in your note, but if you need to note it now, I don't expect the board really. The reservation option is simply her next best option. Right? So if she doesn't work for Bruno, that's what she's going to get. We're going to assume that she's able to support herself at the minimum amount of her biological constraint, either through subsistence farming or through a pension or through something like that. Okay? So that's the beginning point. Is everyone comfortable with that? Give me some thumbs up. Okay? So Angela's reservation indifference curve. What is that going to be? This is going to be the minimum required for Angela to work. So all the options along this, along what we're about to draw, right? So I actually haven't drawn it, but everywhere along Angela's reservation, it's basically just that absolute minimum amount. The minimum required combination of B and T that she needs to work. The minimum required, I can write that out even, combos of B and T that Angela requires to work. Okay, so now what we're going to find is it's going to sit above, right? It's going to sit above the biological constraint, because obviously she's not willing to work the minimum amount she wants to survive. She's going to want to work for more. And so what we're going to see is that as T decreases, in other words, she works more, right? She requires more and more than her biological constraint, right? And I'm using a very like loose wording here, but why is it more and more than her biological constraint? Due to the increased disutility of work, right? So if you don't get what I'm saying, keep paying attention and it should make sense. If she's gonna work a little bit, right? If she's gonna work a little bit more, then she's just gonna require a little bit more than her biological minimum, right? So if you're only gonna work an hour, she's gonna be like, okay, I'll work an hour for a little bit above what I need, you know, a little bit extra, okay? But as you have her work more and more and more, she's gonna need more, quite a bit more than the biological constraint, right? That's what I'm saying. As T decreases, she requires more and more than her biological constraint. In other words, she requires even extra above it. So we see that her reservation and difference curve, right? Angela's reservation and difference curve has an increasing distance from the biological constraint due to the disutility of work, okay? Due to her disutility of work. So we can even draw that here, and we can show that that difference here is the disutility of work, all right? So this is going to be a reservation in difference curve. And that in a world where people can't just be forced to work for anything, they actually have the right to say yes or no, that is the one that we're most interested in. That's the bottom. That's the minimum that she'll ever accept, right? It's the minimum required combination that Angela requires to her. She has the freedom to decide whether or not she wants to take that job, okay? And therefore, right, we're going to be able to therefore, sorry, just have to catch myself here, we can therefore define this area, right, as the economically feasible set. Okay, so that there is my economically feasible allocation. Economically feasible allocation. All exists here, in this part here. Are there any questions? Please let me know now. Otherwise, give me thumbs up if you're ready for me to move on. Cool, 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 cool. I think some people will probably just be noting things down. Yes. So while you're noting things, just take 30 seconds to finish your notes while I just review where I am. Okay, sweet. All right, great. So no question coming through. I'm now going to erase the board. Going one, going twice, and we're going. So the next thing, it's sort of like a continuation of this, but we're going to just call it the next section, is the Pareto efficiency curve and the distribution of surplus. So you can think of those allocations, right? That's all surplus. That's everything above the minimum that Angela requires. Remember, for Angela, that minimum that she requires, that's not surplus, because that's equal to her reservation option. So she's like, anything above my reservation, that is surplus. That's what we would refer to as economic rent. Okay? So that's what we're going to be talking about. Who gets what in this situation? Okay, so 5.8 And I'm aware that we just crossed over the 12 o'clock mark, but we don't really have much left. So Pareto efficiency curve and sharing surplus. Okay, so let's redraw again. A lot of drawing across today. B and T. And we're going to draw the T little frontier. And now we're not interested in her biological constraint, right? We're interested in her reservation in difference curve. Okay? So we're interested in the reservation in difference curve. I'm just gonna curve this a bit more so I've got a bit more space to work with. Okay, cool. So we set this thing up, right? We set this thing up. It's not perfect, but I'm going to get over it. And now we've got our economically feasible set. We know what all of our economically feasible sets are. Now, let's begin. What if Bruno has full power? So let's say that Bruno gives Angela a take it or leave it option. Okay? If Bruno is going to give Angela a take it or leave it option, in other words, Bruno has maximum power. He owns the land, and there's nothing protecting Angela in terms of minimum wage or anything like that. So if he has a take it or leave it option, right? Then this is how we're going to work it out. Yes, thank you for asking the question. Thank you for answering the question. This is the reservation in difference curve. But thanks for asking because I want to always make sure I've got it down. So if Bruno gives Angela the take it or leave it option, what is he going to do? It's another situation of simply, right? We want to, Bruno will maximize his share when MRS equals MRT. So guys, this is exactly like the biological example, where rather than satisfying her biological constraint, we now need to satisfy the reservation in difference curve. So it's much the same, right? Where we're going to the least space because we're going to be adding to this graph. So it's much the same. He's simply going to have to find the point where the MRS is equal to the MRT, okay, at this point. All right, and in that case, Bruno will maximize his share when MRS equals MRT, okay, and this will be the T star as always, okay, and we're just going to call this, I don't know, let's call it, we're just going to call it A and B. So we're going to call this point A and this point B. Okay, so if Bruno maximizes his share at this point, and he's got the take it or leave it option, right? Then Bruno will pay, or in this case, I'm not going to say it like that. Angela get B, and Bruno take A, B. Okay, so basically what I'm saying is that we're gonna the sharing point is going to occur here, right? The sharing point is going to occur here. At B, right? At B, if Bruno has maximum power, right? At B, if Bruno has maximum power, that is the point where we would find the sharing. I need to just get some thumbs up. Does everyone understand? I feel like I'm muddling my words, but also it's understandable. So we're going to share at this point. So Angela gets paid this amount B, right? Okay? And Bruno takes the difference, just like before. Now, what would be the situation? What would we call the situation if Angela had maximum power? What if Angela had all the power? What if Angela was allowed to use Bruno's land and didn't have to pay Bruno anything? Then where would the sharing point be? Someone give me an answer and you'll just get a lot of brownie points. Where would the sharing point be if Angela owned the land? We did this already. Guys, what would be the point? Anyone? Going once? Going twice? Well done, Matthew. That's exactly the answer. Thank you for answering it, asking it. So, if she had maximum power, then we find, right? This is highest indifference curve, just some indifference curve. We would go to at B, at A, if Angela has max power. So, what does this tell us now, guys? If we have maximum power for Angela, we're A. If Bruno has maximum power, we go down to B. So, if we were somewhere in between, I'm going to erase here. Let's say if we were randomly, if there was sort of like this shared power, like, I don't know, if they both have a bit of power over one another, then they would find themselves at some point in the middle, right? They would find themselves at some point in the middle, random middle indifference curve, okay? So if they shared the power, they would also find it there. And the major assumption here, right? The major assumption here is that all the indifference curves have the same marginal rate of transformation along this point. So if you had an indifference curve here, 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 or at any point here, the marginal rate of transformation, the slope of the indifference curve, is always the same. So we're going to find the points where MRS equals MRT always along this point. So this tells us, right, something very, very important, and that is, right, that our, what we refer to as the, I'm just using the green for drawing, right, the Pareto efficient curve. This is my Pareto efficient curve. Shows all possible Pareto efficient allocation. Everywhere along here, the MRS is equal to the MRT. And we have this Pareto efficient situation, this Pareto efficient curve. All right, this is my Pareto efficient curve here. Shows all possible Pareto efficient allocation. Right? And guys, I want you just to look up. Just look up here. Please look up. No matter what the power dynamics, remember the power dynamics will determine where we sit here. But let's say we were at the middle point. Let's say this random middle point. Angela doesn't care about any difference between these. She doesn't care about the difference between anything along this indifference curve. But you can see that it's only along this line that Bruno's maximize, right? So no matter where Angela is, no matter what indifference curve Angela is working on, Bruno's maximized along here. So we're always going to be here because Angela's the same if we're there, we're there, we're there, we're there. But it's going to be along that line that Bruno is maximized. So we know that it is that it is Pareto efficient. Please give me some thumbs up if we understand this. We're going to move on to the last two examples, and then we are going to call it a day. So thumbs up if there's any questions, please ask. Going once, going twice. Alrighty ho, let's do this. What happens to the distribution of the surplus when Angela has power? Okay, what happens? Okay, so Alexa, you've asked what happens to the distribution of the surplus when Angela has power. So again, we're saying we're going to be at A if Angela has maximum power, right? So at A, that means that Angela gets everything, right? Angela gets everything and Bruno gets nothing. So Angela having maximum power, and it's very important that you guys understand maximum power, would essentially mean she essentially owns the land, right? No, or she's allowed to do whatever she wants. Okay, so if Angela has all the power, Bruno gets nothing, right? Bruno gets nothing, and Angela takes everything. Alexa, give me a thumbs up if that makes sense to you, and everybody in general, if that answers the question. Cool. So Jamie, you asked, I don't understand why points A and B are Pareto efficient because they are worse off. Okay, cool. So it all depends, right? They're not worse off, right? It all depends on the power situation. So remember, each indifference curve here represents a different power situation. Okay? We're going to operate on her reservation indifference curve, right? When she's got no power. She has to just accept. There's no way she can have more. So B would be optimal. The reason that B would be optimal, if we stay on the reservation indifference curve, is because every point along here, Angela is equally happy, but B is the point where we maximize Bruno's outcome. So everywhere along here, Angela is equal, but Bruno's best at B. So if we're going to be on reservation indifference curve, we're going to operate at B. Likewise, if we're going to be in the maximum power situation, we're going to operate on the highest indifference curve, and we're going to have a tangent. Or if we were on this random middle indifference curve, Jamie, please pay attention, right? Is that if we're here, 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 Angela doesn't care. They're all the same. But it's at this point, right? It's at this point we can call point C that Bruno would be best off. Okay? It's at that point that we would see Bruno best off. So if Angela is equally happy here, we can move to C without making Angela worse off, but we managed to make Bruno better off. Right? So we're always going to maximize Bruno here, and Angela will be just equally happy. Remember, whenever we're assessing the scenario, we're going to assume we have a fixed indifference curve for Angela. I hope this kind of makes sense to you. Let me know if I answered that question, Jamie. Give me a thumbs up or type into the thing. Cool. Thank you. So we have come to the end of this major part. We're going to finish off with two cases, and then I think we're going to call it a day. And I'm going to tell you which final sections that we didn't manage to cover, but I had a feeling we wouldn't make it there. So I'm going to erase this if there's no more questions here. Going once, right? Going twice, and we're good to go. Okay, cool. So now what we're going to be looking at, right, is 5.9, and I sort of combine them, 5.9 and 5.10, right? And this is essentially going to be politics, bargaining, and sharing. Politics, bargaining, sharing. And what I'm doing here is I'm essentially looking at the case. Okay, so you guys can know that I was given access to some slides of yours, and I've been using these to identify what's important. And then I looked at the textbook for better explanations and things like that. But just so you know, I'm basing most of this off of what was shown to be the most important along here. Okay, cool. So let's say that let's do the first one, case one. Government gives Angela, or government will give Angela a grant of 5 Bs if she does not work. Okay? So Angela is going to get given a grant of, we're just going to use, I'm using a random number 5. Okay? If she's not going to take the job. So if she doesn't work for Bruno, that's what she's going to get paid. And that's going to influence the decision here because she's got a new reservation option. So we're going to put B here. We're going to put T here again. We're going to draw our feasible frontier, right? Now, we're going to start by just saying, right, let's say there was some reservation option before. I'm actually going to remove feasible frontier because you guys know what that is, right? Just for the sake. So let's say this is the old reservation indifference curve. We're going to call that the old reservation indifference curve, right? And this was some, right, some amount, some reservation option. Okay? Now, we see the government said to her, no, we'll give you 5. So we'll assume 5 was more, right? We'll assume 5 was more. So this is the new reservation option. She's got a new reservation option, right? Which is equal to 5. So what we're going to see now is that Angela's indifference curve is going to look just like the one before. So I know my drawing is terrible, right? But it's going to look just like the one before, except it's going to be higher, right? Because of this new reservation option. So that's the old reservation indifference curve, and this is the new reservation indifference curve. Okay? We've got a new reservation indifference curve. And then it's back to where we were before. We're going to see that it's at this point, right? Where we have equal slopes, right? And it's the same point, right? It's the same point that she was at before, right? It's the same T amount that she was at before, T star. But now, and this is the critical part, now, right, and the fact that this cuts through here really doesn't mean anything. So, in fact, I'm going to remove this just so that you guys can see what I'm doing here. Okay, so don't worry about that. She's got a new reservation option, which is 5 bushel, okay, which reads across, right? And now, if this is the situation, right? Bruno's gonna have the same approach. He's gonna give her a take it or leave it option. But now he can't give her this take it or leave it option. Right? This was the option he gave before. So I'm gonna call this, yeah, this is the Bruno's offer before. And now Bruno has to make a new offer in order for her to take, for Angela to take it. So this is going to be Bruno's new offer. Because he has to satisfy the new reservation constraint. All right? And so this is going to be the final outcome, right? The final sharing outcome. And that means that this is going to be, right, Bruno's payoff, and this is going to be Angela's payoff. So Angela's payoff has increased by the difference that we see here, right? Bruno's has decreased. So we see this is the new Bruno, and this is for Angela. All right, so the introduction of, right, the new higher reservation option results in Bruno Bruno's B decreasing and we see Angela's bushels increase, because otherwise Angela will not take it. Let me know if that makes sense to you guys, right? Please give me a thumbs up if you follow this. Cool. Any questions? Are there any questions around? Right? I'm assuming you're not giving me thumbs up, but you're not asking me questions because you're busy, right? Fine. Okay? But if I don't get a question or I don't get like a please explain again, I'm going to assume we're all good. Okay. Cool. Awesome. So we got one last example and then we're going to call it a day. Okay. So it's going to be a very similar example with a different kind of constraint. All right. Cool. So I'm going to erase this now, right? I'm going to erase this now, going once, going twice, and we're good. So the last option, the last case that we're going to talk about, next case, is the government set a minimum wage of 5 bushels and limit work hours to a maximum of 4. So we're going to analyze this kind of policy through this lens. What do we think is good? What do we think is bad about it? B, T, feasible frontier. You guys know feasible frontier. Okay, sweet. So we'll start with the original reservation and difference curve. Okay, reservation option. And that's going to be here. All right. And now let's say that they set this minimum wage of 5 bushels and limits work hours to 4. So let's say that that point, remember this is always going to be 24, right? So let's say that this point happened here. Where am I? Let's say at this point, so this is 20, right? And there we go. Right, that's 20, and this is my minimum wage of 5. So this is what they've said. They said you cannot pay less than 5, and you cannot work more than 4 hours. So you can't push anyone that way or anywhere below. Okay. So if Byron, if what's his name again? Bruno were to operate, were to make Angela work here, then we would see, right? We would see that Angela would be operating on this indifference curve. Okay? So remember the purple one is the reservation indifference curve. And this one is our is just sum indifference curve I0. Now, what's the problem with this point, right? So the problem with this point here that we can see is that at this point, right? At this point, we see that the MRS is not equal to the MRT. You can see by the slope of the indifference curve is flatter than the MRT. So in this case, MRT is greater than MRS. Therefore, it is not Pareto efficient, right? It is not Pareto efficient. We would rather move to the point along our Pareto efficient line, right? So we would find that point, let's say, around here. So on our Pareto efficient line, which is where all indifference curves have the same slope as the feasible frontier, right? We would rather move to this point, okay? At this new point, right? I'm actually going to just write it here. So moving here, right? Angela is not better or worse off, but Bruno is better. Therefore, it Pareto dominates. Previous point. Okay, so we can call this, you could maybe call it A, and we can call it B, right? So moving, right? Moving to B, Angela is not better or worse off than A, right? We see Angela is not better off or worse off than A, right? But Bruno is better off, right? Bruno is better off. Therefore, it's Pareto dominates. Therefore, right? Therefore, B, Pareto dominates A. So what does this say? Basically, I'm going to answer your question now, Cameron, right? What does this say? Right? This says that setting a minimum wage will improve Angela and keep outcome Pareto efficient. So if we allowed her to move to this point, right, where we would have some T star, right, and some share of B, if we allowed her to move to this, allowed her to work more, if we allowed her to work more, she'd have to be paid a bit more, but that doesn't make a difference. She doesn't care about the difference between A and B, right? But if we move from A to B, Bruno's amount grows, okay? So setting a minimum wage of 5, right, at 4 hours means isn't really good if we set it with a 4-hour limit. But if we set a minimum wage, right, then we can improve the situation. So if we said that if someone works 4 hours, they need to I'm going to answer that question now. So if we said that someone who works 4 hours needs to be paid 5, right? That's what we said. So we didn't say maximum. We said if someone works 4 hours, they need to be paid 5. Then the scenario would land up at B, right? Because we didn't limit the hours, right? But it would increase, right? It would improve Angela's situation. However, if we limit it to B, if we limit it to 4 hours, then we get stuck at point A. And then doing so is not going to be better for society, right? It's not going to be good because we could move to B, and Angela would be equally happy, but Bruno would be better off. So setting a minimum wage will improve Angela and keep outcome Pareto efficient, but setting a max on hours results in Pareto in efficiency. Okay, so we set that minimum wage. So I might be running around here in a circle. So Stephen, I'm going to answer your question now, right? So, but Angela's working hours exceed 4 hours on the week, and you're correct. So what we're trying to show is that if we took away the limit, we could move to B, right? And we would be good, okay? So setting a minimum wage will improve Angela and keep it up, the outcome Pareto efficient at B. But setting maximum on hours results in Pareto efficiency like we see at A. So doing so is not going to be a good situation. Stephen, tell me if that helps you, right? If I've sorted that situation out. Okay, so remember, A is where we're going to be with our original case. So we're going to land up at A. Okay, so it's not Pareto efficient. And then you, if you were the, you know how they like to ask these questions, you're the economic advisor of the, I don't know, the minister. So you're going to have to give him advice on what to do. What you're going to have to do is show him that, you know, we could move to B and we could make Angela better off. No, we would keep Angela the same, but we would make someone else better off, and it would be Pareto efficient. So you would give that sort of stuff. Okay, give me a thumbs up if everyone's with me and understands things. Give me a thumbs up. Cool, guys. So we started about 10 minutes late, and we've been running now for 2 hours and 20 minutes. I would, you know me, I would carry on forever, but I've got another workshop shortly, and I do feel like we've reached the end of everything that's really important. So there's a third case that can be covered, which is what happens if the transfer. We transfer the land to Angela. We've already done that because we know that Angela is we know that Angela. Sorry, I just blanked. We've done the case where Angela gets ownership of the land. We've seen what that looks like. Okay, there are a few other cases running around that you could probably go look at, check them out, apply the way of thinking. So I'm going to answer these two questions from. So first, I'm just going to answer Cameron because it's easy. Is Bruno worse off at A? Yes, Bruno's worse off at A compared to B, but Angela is the same. So that's the whole point. The whole point is if we get stuck at A, like why? Why should we be at A and move to B, right? Because B is where Bruno will be better off and Angela will be the same. So the total outcome will be better, right? So that's that. Matthew, you say you don't, never mind, you understand. Oh, and Cameron, you asked earlier if indifference curve 0 is the new reservation indifference curve. Not quite, no. The reservation indifference curve still is here, right? This is still the reservation indifference curve because that starts with the reservation option. This is now just the new indifference curve that Bruno essentially has to satisfy, right? So Bruno has to satisfy IC0 in order to keep her happy because A is an option, right? So that's going to be that. Is quasi-linear utility the same as the Pareto efficiency curve? No. Thank you for bringing this up. This is something that I had to talk about. So quasi-linear indifference curves is something that you guys need to go and look at. There was never going to be enough time in this workshop to go through quasi-linear indifference curves. So please make sure that you go look at quasi-linear indifference curves because we did not cover it. It is not the same as the Pareto efficiency curve. It's just a type of indifference curve. So it's just got a bit of a math thing behind it. The theory is the same, right? But it's just got a bit of a math thing behind it. It's a different type of indifference curve. It's a different shape. Hope that helps. Right. So what I haven't covered is pretty much the end of 5.10 and 5.11. Please go check it out. The main thing that we want to take away from here is that it's very clear, right, that biology and technology, it determines what's feasible. But it's power and institutions that are going to determine the distribution. It's the reservation options that the government gives you, that's institution. Minimum wages, that's an institution. So institutions and power determine where do we sit in between here. Well, biology and technology determine what are our options. All right. So yeah, I would just go maybe check out the critique of the model in 5.11, right? And the whole idea of institutions and biology and preferences and things like that. And otherwise, If you guys don't have any further questions, that's us for the day. Thank you all very much for attending. It was really great having you all with me today. Please, we're struggling as much as everyone else is during this really tough time. So please spread the word about our workshops. Particularly, please tell the first years that you know, any first years that you have, please share the stuff with them. Tell them that you really have enjoyed this online workshop experience, if you did. And yeah, we would just appreciate all the support. But yeah, thank you guys very much. You guys know that we are also running workshops for business law, and it's likely that we will carry on with these kind of workshops when term 2 starts. We just need to figure out what term 2 is going to look like first. So cool, guys. Thanks very much. I'm going to hang out. If anyone has any questions, again, you're always welcome to ask them now. My phone number, I'm going to pop it into the group. It's 076-520-3372. You're welcome to pop me a WhatsApp message if anything doesn't make sense to you. Guys, thank you, Joshua, thank you, Robin, thank you, Ruby, right? Danny, thank you so much as well. It's a pleasure pulling through for you guys. Thank you for pulling through for us. It's always fantastic having you guys with us. So yeah, not all is lost because of coronavirus, right? We can still do this thing. We just have to do it a bit differently. So yeah, cool, guys. Thank you all. Jamie, Jenna, Maxine, Stephen, Jared, Shannon. Thank you, guys. Thank you all. It's been great. I've really enjoyed this. And I'm going to hang out in case anyone has questions. If anyone has a question about just things, Smartprep, you're welcome to ask it. I'll hang out for another 20, 30, 40 seconds, and then I'm going to end this meeting. So if anyone has any questions, let me know. Now's your time. Otherwise, cool. Awesome. Shot, guys. Have a blessed day forward. And yeah, I'm going to end the meeting now. So you can pop me a message directly or an email if you have anything. I look forward to seeing all your names on my screen at the next workshop, which I think is tomorrow. Fantastic. Have a great day, guys, and thank you. Cameron, I was about to end the meeting. The Pareto efficiency curve. What do you mean Bruno is maximized on this point? His economics range is only max at the tangency point B. Okay, cool. So Cameron, what I mean by that if we're on the Pareto efficiency curve? So Pareto is here we go. So there's various different power situations that we could find ourselves in. We could find ourselves in a situation where Bruno has all the power, or we could find ourselves in a situation where Angela has all the power, or we can find ourselves in a situation where there's a power sharing, right? Institutions are going to determine that. If there's 0 institutions that protect Angela, nothing to give her subsistence protection, nothing at all, no minimum wages, nothing, then we're going to see that we're going to be at that point, I think, with B, right? But if power is given to Angela, then we're going to see that Angela is going to be on higher indifference curves, right? And simply satisfying her reservation indifference curve is not going to be good enough. Angela will say no, because she's got some other options, which are those institutions. Those institutions have given her those other options, right? So we're only going to see them at that point if she doesn't have power. We're going to see if she has all the power, we're going to be there. And essentially what I'm trying to say is the Pareto efficiency curve shows all the points that we could land up at for every possible situation in terms of power. If Angela has all the power, we're going to be at that top point. If Angela has no power, we'll be at that bottom point. If Angela has some power, we're going to be at some point in the middle. But if Angela has some power, A is not going to be optimal. In this example, and Angela has some power. So, this won't be an option because Angela will say no to this. But Angela is happy to say yes to this, right? So that's going to be an option. If she had a little bit more power, the indifference curve might be higher. And the best point would be along that line there, right? Along our Pareto efficiency curve. No matter what the power dynamic is, we're always going to sit on that Pareto efficiency curve. Cameron, let me know if that answers your question and if that makes sense to you. Please. Cool. Awesome. Thank you, guys. Any other questions? We're good? Yep. No more questions, guys. Awesome. Thank you all for coming. Please spread the word. When you send the workshop notes, where did they appear? I can't see them in the chat. I think you just have to keep scrolling the whole way up. Scroll up there. They should be there. There's a bit of a scroll thing. Okay. Just scroll up, scroll up. Have you found them, Maxine? Have you found them, Maxine? Let me know. No. Okay, give me a second. All right, the notes are going to be coming through now. Hazel, you'll get an email about the recording. All right. So they're coming now. Please download it because as soon as I leave this meeting, it'll be over. Cool. All good, Maxine. You've got the notes now. Please click download. Maxine, are you sorted? Okay, then I'm not really sure. That please just pop us an email. Send an email to info@smartprep.co.za and they'll email it to you. I'm not really sure. I've sent it, but it's not. If you're not seeing it, then there's some sort of problem because I can see it. All right. So I'm going to ask you to please email. Cool, guys. I'm going to end this. I'm going to leave this meeting now. So thank you all very much and have a blessed day. Cheers.
Jamie, what's up?
Oh, how's it?
It's just me, yeah, now. So yeah. Yeah, seems like it went well.
Yeah.